Hello, welcome back. In this video, we'll move on and into some additional topics of microservices. I wanted to discuss a few high-level points regarding the integration of microservices. How do microservices interact and communicate with each other? We'll go into some specific details, but it is a high-level view of the integration patterns and the communication protocols. So, integrating microservices involves enabling the independent services, each often with its own database, to interact and communicate with the application, right? So this is primarily achieved through what is called as IPC, or inter-process communication mechanism, and some strategic integration patterns, which we'll talk about. So Microsoft microservices uses these IPC mechanisms with two main message formats. There is a binary format which is optimized for speed, and then there is the text format like JSON and XML, right, which are optimized for human readability. Let's call it that way. So let's look at the communication mechanisms, IPC communication mechanism. So one is asynchronous and the other one is synchronous, right? In asynchronous, what happens is it's a non-blocking communication style where the client sends a message, to the service and continues its work immediately without waiting for a reply from the service, right? The response comes back later as a separate message. So processes that client sends a message to service processes it, service then sends a message response back to the client, right? And the message channels could be two ways, right? It could be a point to point, or it could be a publish subscribe, right? Point to point is basically when you deliver a message to one single consuming client, usually for direct communications, and publish subscribe when there is a common message that has to be delivered to all attached clients or subscribers, right? It is one to many interaction, like broadcasting an event, for example, right? Now, what are the pros and cons of asynchronous messaging? Well, basically, the pros is that it helps in message buffering. It isolates the client from the service. um, the cons is there's an additional operational cost. A separate messaging system must be run, and complete complexity in implementing a request response flow. Now, that is asynchronous. In a synchronous communication mechanism, which is a request response IPC, this happens more real time, blocking communication style where the client sends a request and pauses its work, waiting for the immediate response from the service, right? The protocols typically followed here are REST and Thrift. Let's look at each of them. REST is representational state transfer. It is the most popular, common, simple protocol using HTTP to communicate, right? The basic concept is that there is the resource, which is a customer or a product, is manipulated using HTTP verbs like get, post, put, post and delete, and there is a URL. So it's simple, familiar, and enables real-time communication. But the client has to know the exact URL to talk to the service, and the services must run concurrently. Thrift is another protocol from Apache. It uses an IDL, like interface definition language, for defining APIs. It generates code, client-side stubs and server-side skeletons for multiple languages, right? And it supports various formats, JSON, etc. Now, let's look at some of the integration patterns. While IPCs handle communication, integration patterns define how the services interact to solve business problems. So the first one is API gateway. API gateways, they act as a reverse proxy between the clients and microservices. It's a single point of entry for all client requests. And then it routes the request to the appropriate service. It hides the location of individual services from the client, right? So if you take, for example, Azure API management or AppIm, it accepts API calls, it verifies the credentials, the API keys and the JW tokens. enforces quotas and limits, and caches the responses. The second pattern would be the event-driven architecture. Since microservices typically use data based per service pattern, data synchronization is now complex. The event-driven patterns change communication. When a specific event is triggered in a publisher service, an event manager notifies all interested subscriber services. The system publishes an event every time its state changes. Okay. The third is the compensating transactions, which is similar mechanism used to undo a series of completed tasks when a subsequent step in that step falls. Okay. Fourth is competing consumers. Here you allow multiple concurrent consumers to process messages from the same communication channel. Okay. Also, we can talk about some Microsoft Cloud Azure services that enable integration. There is Azure Service Bus, which provides a robust messaging delivery service for service-to-service communication, supporting both real-time and non-guaranteed communication. Then there is Azure Queues, which provide cloud storage accounts used to queue messages between applications, often used for uh, asynchronous communication. So these are the main messaging protocols, communication types, and styles usually implemented in a microservices architecture. Right. With this, I come to the end of this topic. Hope you like the content, and in the subsequent chapter sessions, I'm going to talk about other aspects about microservices. Thank you for watching.